The iconic James Webb Space Telescope has been making epic headlines since its launch in 2021. This cutting-edge technology has been an instrumental tool in astronomy, providing new insights into the fascinating origins of the universe, the formation of galaxies, and the search for life beyond our solar system. However, the most recent discovery revealed something terrifying that could alter our entire perception of reality as we know it. Ready to be blown away? The James Webb Telescope has just captured a chilling new image of the very edge of the universe. What has NASA's newest telescope discovered, and how does it change astronomy as we know it? Stay tuned, and let's find out in this video. Traveling to faraway planets has always been a fantasy for humans. Thanks to the powerful James Webb Space Telescope, we're one step closer to this crazy dream. Although over 3,000 exoplanets have been discovered, most of them have only been detected through a dip in light caused by their movement in front of their host star. Webb, however, changed the game by capturing the first direct image of an exoplanet in September 2021. This noteworthy occasion marked a giant leap forward in astronomy. The exoplanet, named HIP 65426b, was discovered in 2017, and getting a good look at it required using 2 of Webb's cameras, several filters, and the telescope's coronagraphs. These tools allowed us to block out the central star's light and get a clear view of the planet's features, and let us tell you, it did not disappoint. This colossal gas giant turned out to be about 12 times the size of Jupiter and 100 times further away from its star than our Earth is from the Sun. It was genuinely an extraordinary find. The universe is endlessly captivating and enigmatic, filled with secrets and marvels exceeding our wildest imaginations. From the vast expanse of the cosmos to the tiniest subatomic particles, every corner of the universe holds mysteries waiting to be uncovered. It's where time and space bend and warp, where black holes devour everything in their path, and where the very fabric of reality is constantly being rewritten. The universe continues to astonish us and is a never-ending source of wonder. Despite all our advances in science and technology, there is still so much we don't know about what lies beyond the unmapped. But the inception of the James Webb Telescope changed that. It has helped unravel some of the most baffling riddles and answered some of the most puzzling questions that have long troubled scientists. One such perplexing question is, what is at the edge of the universe? The James Webb Space Telescope first took the world by storm in July 2022 when NASA released the telescope's first new images of stars, galaxies, and an exoplanet. Webb's image provides fresh insights into how galactic interactions may have driven galaxy evolution in the early universe. The first image the James Webb Telescope released displayed a group of galaxy clusters called SMACS 0723. These galaxy clusters act as a magnifying glass, a phenomenon known as gravitational lensing. Gravitational lensing occurs when the gravity of a giant object, such as a galaxy cluster, bends the light from objects behind it, making them appear bigger and brighter than they actually are. The gravitational lensing effect created by SMACS 0723 allowed the James Webb Telescope to capture its first deep field view, including ancient and faint galaxies that have never been seen. This was a significant achievement for the telescope as it demonstrated its ability to capture images of distant and faint objects once beyond the reach of other telescopes. The image of SMACS 0723 was taken by the James Webb Telescope's near-infrared camera, which shot images at different wavelengths of light over 12.5 hours. This allowed the telescope to snap a detailed and comprehensive view of the galaxy cluster as it appeared 4.6 billion years ago. The first release from NASA's James Webb Space Telescope comprised images of celestial objects such as the Kina Nebula, the Southern Ring Nebula, Stephan's Quintet, and WASP-96b, an exoplanet located 1,150 light-years away from Earth. The spectrum seized by Webb of WASP-96b is the most detailed spectrum of an exoplanet to date. It has different wavelengths of light that offer unique information about the planet and its atmosphere. The spectrum shows evidence of water clouds and haze in the planet's atmosphere, demonstrating Webb's ability to analyze atmospheres hundreds of light-years away. The Southern Ring Nebula is a huge planetary nebula located 2,000 light-years away from Earth, containing an expanding cloud of gas around a dying star. Webb helped expose previously hidden details about the nebula, including the shell of gas and dust released by the dying star and how the star shapes the gas and dust cloud. The Southern Ring Nebula was previously considered a simple dying star that had expelled its outer layers. The recently released image from the Webb telescope has revealed that a third star may be involved in the nebula's formation. The mid-infrared instrument showed that the white dwarf wasn't invisible but glowing red, surrounded by a haze of cool gas, leading scientists to believe another star exists. There are intriguing shells around the outer edges of the nebula, which a third star could have caused. All the gas and dust seen must have come from that one star. Still, according to Joel Kastner, an astronomer at the Rochester Institute of Technology in New York and one of the study's co-authors, the companion stars tosses in specific directions. Stephan's quintet is a compact galaxy group located 290 million light-years away in the constellation Pegasus. 4 of the 5 galaxies in the group are locked in a cosmic dance of repeated close encounters. Finally, the Carina Nebula is a stellar nursery located 7,600 light-years away from Earth, where stars are born. Webb's image discloses formerly invisible areas of star birth within the nebula. The James Webb Space Telescope, the newest addition to our stargazing arsenal, detected an exoplanet unlike any other. This celestial oddball turned out to be a brown dwarf, more extensive than a planet but not quite big enough to be a star. The observations made by this great telescope have revealed some enticing facts about this celestial body. The brown dwarf, known as VHS 1256b, emits a dim reddish glow due to the modified form of fusion that occurs in massive objects but is too tiny for hydrogen fusion. Even more peculiar, Webb discovered silica clouds surrounding this little guy, which had never been seen before in a brown dwarf. The intrigue doesn't stop there. The exoplanet is relatively young and small for its kind, meaning there is much to learn from it. Webb even identified various atmospheric chemicals, including water, methane, carbon dioxide, and potassium. The study of this discovery has suggested that there is turbulent vertical mixing in the exoplanet's atmosphere, which means that carbon dioxide from deep down is being dredged up to mix with the methane high up in the atmosphere. What a strange and wondrous world we live in. Have you ever heard of the phantom galaxy? It may be elusive in the night sky, but its brilliance dazzles when captured in infrared with the James Webb Space Telescope. By combining images from the Hubble and Webb telescopes, researchers have created a mesmerizing composite image that showcases the galaxy's spiral structure and fiber-like structures of heat-emitting dust and gas emanating from its radiant center. This enchanting image is part of a larger international project called FANGS, which uses Webb, Hubble, and several ground-based telescopes to capture 19 nearby star-forming galaxies in the infrared. By utilizing Webb's capability to see through dust and gas, astronomers hope to understand the puzzles of star formation and interstellar space. With the ability to accurately measure the masses and ages of star clusters, pinpoint star-forming regions, and explore the nature of dust in space, the addition of crystal-clear Webb observations promises to revolutionize our understanding of these bewitching galaxies. In February this year, the Webb telescope made a surprising galactic discovery in the distant universe. It somewhat answers the mind-boggling question that has bothered humans for centuries. What is at the edge of the universe? Astronomers used the James Webb Space Telescope to observe 6 enormous galaxies that existed between 500 million and 700 million years after the Big Bang. These galaxies were unexpected because they were as mature as our own, and it was previously thought that only tiny baby galaxies existed then. The galaxies appeared as sizable points of light, and the team was stunned to see them. The amount of mass discovered means that the known mass in stars at this period of our universe is up to 100 times greater than thought before. These objects are way more massive than anyone expected, said Joel Leha, an assistant professor of astronomy and astrophysics at Penn State University. We expected only to find tiny young baby galaxies at this point in time, but we've discovered galaxies as mature as our own in what was previously understood to be the dawn of the universe. Researchers used the Webb telescope to observe the universe in infrared light, which is invisible to the human eye and is capable of detecting faint light from ancient stars and galaxies. By peering into the distant universe, the observatory can see back in time up to about 13.5 billion years ago. Gigantic galaxies detected by the Webb telescope conflict with current theories of early galaxy formation, leading scientists to rethink their understanding of how galaxies evolved. The researchers, led by Leha, were startled to see these galaxies appear as large points of light in the telescope's first high-resolution images. They were so astounded that they initially thought they had mistakenly interpreted the data. However, after analyzing the data further, they found that the galaxies were real and much more ample than they had anticipated. To determine why these galaxies grew so quickly, the team plans to take a spectrum image of the galaxies. This involves splitting light into different wavelengths to define its constituents, allowing the researchers to understand the age of stars and the speed at which galaxies form stars. The James Webb Space Telescope, JWST, the most advanced space observatory ever built, continues to revolutionize our understanding of the cosmos with its unprecedented capabilities. Since its launch, JWST has provided breathtaking images and groundbreaking data that have unveiled previously hidden aspects of the universe. One of the most remarkable achievements of JWST is its ability to peer deeper into space and time than any telescope before it, capturing the light from some of the earliest galaxies formed after the Big Bang. These observations have not only amazed scientists but also challenged long-standing theories about the formation and evolution of galaxies. One of the most intriguing discoveries made by JWST involves a series of ancient galaxies that existed when the universe was only a few 100 million years old. These galaxies, observed between 500 million and 700 million years after the Big Bang, are astonishingly massive and mature, defying previous expectations. Astronomers had anticipated finding small infant galaxies from this early epoch, but instead JWST revealed galaxies that are comparable in mass to our own Milky Way, suggesting that galaxy formation in the early universe was more complex and rapid than previously thought. This discovery has prompted a re-evaluation of existing models of galaxy formation and evolution, as scientists now seek to understand how these massive structures could have formed so quickly after the universe's birth. Another significant finding from JWST is its detailed observations of exoplanets, planets that orbit stars outside our solar system. JWST's advanced instruments have allowed astronomers to analyze the atmospheres of these distant worlds with unprecedented precision. In one of its early missions, JWST captured the first ever direct image of an exoplanet, HIP 65426b, a gas giant located about 385 light-years away from Earth. This exoplanet, which is about 12 times the size of Jupiter, was observed using multiple filters and cameras aboard JWST, providing scientists with detailed information about its composition and atmospheric conditions. The discovery of water vapor, carbon dioxide, and other molecules in the atmospheres of several exoplanets has raised exciting possibilities about the potential for life beyond Earth, as these elements are essential for the development of life as we know it. JWST has also contributed to our understanding of stellar nurseries, regions of space where new stars are born. The telescope's powerful infrared capabilities have allowed it to penetrate the dense clouds of gas and dust that obscure these regions from visible light telescopes. One such region, the Kina Nebula, has been imaged in stunning detail by JWST, revealing previously unseen areas of star formation. The images show young massive stars emitting intense radiation and powerful stellar winds, which shape the surrounding gas and dust into intricate structures. These observations provide valuable insights into the processes that drive star formation and the dynamic interactions between newborn stars and their environments. In addition to studying star formation, JWST has also made groundbreaking discoveries regarding the death of stars. The telescope has captured detailed images of planetary nebulae, the remnants of stars that have shed their outer layers as they near the end of their life cycles. One such example is the Southern Ring Nebula, located about 2,000 light-years away. JWST observations have revealed complex structures within the nebula, including concentric shells of gas and dust which were ejected by the dying star. These images have allowed astronomers to study the final stages of stellar evolution in unprecedented detail, providing new insights into how stars enrich the interstellar medium with heavy elements that later contribute to the formation of new stars and planets. Perhaps one of the most profound implications of JWST's discoveries lies in its ability to challenge and refine our understanding of cosmology, the study of the origin, structure, and evolution of the universe. By observing galaxies at different stages of their development, JWST is helping scientists piece together the history of the cosmos from the earliest moments after the Big Bang to the present day. The telescope's observations of distant galaxies, gravitational lensing, and the cosmic microwave background are shedding light on the universe's fundamental processes and advancing our knowledge of the cosmos in ways never before possible.